Okay, here's example 3 on this. Example 5 as it's written here, but it's the third example that deals specifically with solving a trinomial using the method of completing the square. So we've done 2 of these fully, so this is one that I hopefully will be able to go through a little bit more quickly. Just study this if you're still having any problems and see if you can follow how things move around. Okay, so we like to begin these problems where we're completing the square. Okay, so remember that's going to be your key phrase here for this technique, completing the square. So problems that involve completing the square, we like just to have the x squared and the x term on the left. So let's begin by moving the plus 5 over to the other side. And as it crosses over the equal sign, it's going to become minus 5. And this is going to be sort of where we come back to. This line here is where we come back to with the completing the square method. Okay, so there are 4 basic steps that start us off always. And before we start each of those, let's write down what b is, because b is the one thing that we need to know. And b is the number in front of x, coefficient of x. So in this case is negative 4. Okay, so let's go now. So first step, step 1, is to divide b by 2. So that's negative 4 divided by 2 is negative 2. Step 2 is just to square that number. So minus 2 squared is plus 4. Step 3. Okay, well with step 3 what we're going to do is we're going to go back to this equation that I've asterisked. I'm not even sure if that is a verb. I doubt it very much, but it'll work for us. Okay, so it was x squared minus 4x. I'll leave a little bit of space there, and I want the minus 5 on the other side. Now what we do is the number that we just worked out in step 2, okay, which was plus 4, we add that to both sides of the equation. Remember, what you do to one side, you have to do to the other side. Okay, now the effect of that is to have completed the square here on the right hand side. We now have this expression here on the on the left hand side. The expression on the left hand side of this equation is now a perfect square, and we'll write it as a perfect square. So we're going to write this step 4. And remember what we do, it's always x, and then whatever we got in step 1, minus 2, x minus 2, and we square that. Okay, on the other side, we have negative 5 plus 4. Now negative 5 plus 4 is minus 1. And that is going to be interesting. Okay, that's going to be interesting because we have a perfect square equal to minus 1. And although we haven't done it for a little while, complex numbers are going to come back in here. You remember those complex numbers? Where we had the I was equal to the square root of minus 1, remember? Okay, so that's going to come in here right now. So, to solve this, sorry, I've got some extra stuff on the screen here, but to solve this, we want to get rid of the square. And to get rid of a square, we take the square roots of both sides. So that's going to be x minus 2. If you take the square root of this side, it'll cancel with the square, so x minus 2. Remember, we have to take plus or minus the square root of the other side, minus 1. So that's going to be x minus 2 is equal to plus or minus, okay, well the square root of minus 1, I'm going to do this a little bit more slowly than maybe I have to. The square root of minus 1 is I, so we could just replace this as with I, but in case when you're doing it you get a number other than negative 1, I want to go through it a little bit more slowly than that. So if we have a square root of a negative number, we're going to write it as a product with negative 1. So it's going to be 1 times negative 1. Okay, plus or minus square root of 1 times negative 1. Or, if you want to, I think we probably prefer to do it this way, we can just write it the square root of 1 times I. The I is not under the square root sign. Okay? Well, the square root of 1 is 1, so this is just going to be x minus 2 equals plus or minus, the square root of 1 is 1i. Okay? And now if you want the x on its own, If you want the x on its own, just bring the minus 2 across, and that's going to give us x. Move the minus 2 across, becomes plus 2, or just 2, plus or minus 1i. Okay? X equals 2 plus or minus 1i, which is very often going to be written as x equals 2 plus or minus I. Either of those ways to write this is okay. But probably the way you're going to see it most often is like this. X equals 2 plus or minus I. I is the same as 1i. And then to see the two individual equations, it would be 2 plus I and x equals 2 minus I. Now, what I want you to see here is the relationship between these two. Okay? 2 plus I and 2 minus I. It's a little while since we've done these, but these are the complex conjugates of one another. Those two are complex conjugates of one another. Now, it's a known fact about quadratic equations that if they have one complex number as a solution, then the conjugate is also the solution. Okay? So complex solutions always come in conjugate pairs. Okay? Complex solutions always come in conjugate pairs. Now that is something you need to remember, because it will save you a little bit of work from time to time, and other times it can be very helpful. So we've done that example, and the solution to that example is x equals 2 plus I and x equals 2 minus I. Those are the solutions there. But let's say, for example, now, and I don't want you to get confused, this is a separate example, same topic. Let's say that I told you that the solution to an equation, one of the solutions to an equation was 3 plus 5i. Could you tell me what the other solution is? So if that's one solution, could you tell me what the other solution will be? Well, the complex solutions, so this is a complex number because there is an I in it, so this is a complex solution. They always come in conjugate pairs. So if 3 plus 5i is a solution, then 3 minus 5i is also a solution. Okay, 3 plus 5i is a solution, 3 minus 5i is a solution. Okay, so you're going to see that as you do some more problems, so the very best of luck with those. Thank you for watching.